To calculate voltage drop for pole lights, firstly determine the total load. The total load is calculated by multiplying the number of lights by the wattage of each light. In this example, 12 lights multiplied by 400 watts each equals 4,800 watts. Secondly, calculate the load current. To find the load current, divide the total load in watts by the supply voltage. Assuming a 220 volt single-phase supply, the load current is 4,800 watts divided by 220 volts, which equals 21.82 amps. Thirdly, determine the distance between the third pole and the distribution board, or dB. The distance to the first pole is 110 meters, and the distance between each pole is 22 meters. Therefore, the distance between the third pole and the dB is 110 meters plus 2 times 22 meters, equaling 154 meters. Fourthly, calculate the conductor resistance. The conductor resistance is 2 times the conductor length multiplied by the conductor resistance per unit length. Assuming a copper conductor with a resistance of 17.24 milliohms per meter for a 4 square millimeter cable, the resistance is 2 times 154 meters times 17.24 milliohms per meter, which equals 5.36 ohms. Note that the factor of 2 accounts for both the outgoing and return paths of the single-phase circuit. Fifthly, calculate the voltage drop of the third pole. The voltage drop is equal to the current times the resistance according to Ohm's law. Therefore, the voltage drop is 21.82 amps times 5.36 ohms, which equals 116.7 volts. Therefore, the voltage drop between the distribution board and the third pole light is 116.7 volts. Keep in mind that this calculation assumes a constant load and uniform spacing between the poles. In a real-world scenario, factors such as temperature variations, conductor material impurities, and connection losses could affect the actual voltage drop. Moreover, it is essential to verify that this voltage drop is within acceptable limits according to relevant electrical codes and standards. For example, the National Electrical Code, or NEC, provides guidelines for maximum allowable voltage drop in branch circuits and feeders. A typical recommendation is to limit voltage drop to no more than 3% in branch circuits and no more than 5% in feeders, resulting in a total voltage drop of no more than 5%. The NEC also provides tables, such as Table 310.15b16, that specify the ampacity of different conductor sizes based on insulation type and ambient temperature. These ampacity ratings are crucial for selecting the appropriate conductor size to prevent overheating and ensure safe operation. In addition to conductor resistance, other factors can contribute to voltage drop, including the impedance of transformers, switchgear, and other equipment in the circuit. To accurately determine the total voltage drop, it may be necessary to perform a comprehensive power system study that takes into account all of these factors. Power system analysis software can be used to model the electrical network and simulate various operating conditions. These simulations can help identify potential voltage drop issues and optimize the system design to minimize losses and improve performance. When selecting conductors for lighting circuits, it is also important to consider the environmental conditions in which the conductors will be installed. Factors such as temperature, moisture, and exposure to chemicals can affect the insulation and overall performance of the conductors. Using conductors that are specifically designed for outdoor or harsh environments can help ensure long-term reliability. Furthermore, proper installation practices are essential for minimizing voltage drop and preventing other electrical problems. This includes ensuring that all connections are tight and secure, avoiding sharp bends in the conductors, and providing adequate support for the cables. Regular inspection and maintenance of the electrical system can also help identify and address potential issues before they lead to significant voltage drop or other performance problems. This may include checking connections for corrosion, testing insulation resistance, and verifying the accuracy of voltage measurements. By taking a proactive approach to electrical system maintenance, it is possible to maintain optimal performance and minimize the risk of equipment failures. In summary, calculating voltage drop in lighting circuits requires careful consideration of various factors, including load current, conductor resistance, and environmental conditions. By following a systematic approach and using appropriate tools and techniques, it is possible to accurately determine voltage drop and ensure that the electrical system meets applicable codes and standards. Remember to consult with qualified electrical professionals for any electrical work or system design modifications.